Hello everyone, I'm Ricky and welcome to the Dev Method. Enums allow you to define a type with possible variants. So in this video we're going to define our own enum. We're going to discuss the option type, which is an enum from the standard library, and then we're going to wrap it up with some pattern matching to match on the different variants of the enum. Enums can be a better way to express an idea than a struct. So here in this first example, we have two different ways to express an IP address. We have a v4 and a v6. So looking at this example here, on line 15, I have the enum. So you have enum space and then the name of it. And then within the enum block, that's where you define all your different cases. So here we have a case v4 and then separated with a comma. And on the next line, we got v6. Further down on line 21, this is where we have a usage of the enum. So notice it's the enum name and then colon, colon, and then the case or the variant. So in this case, it is a v4. And then line 22 is the same thing. And then here's an example of passing in an enum as a function parameter. So notice we could just use the for variable, or we could just pass in the enum as is. So pretty simple. Let's take it a step further. So back on line 15, we have the IP address kind, but now let's look at the struct. So here we have the struct IP address, and it actually has two different fields. We have kind, which is an IP address kind, and then we have address, which is represented as a string. So note on line 27, when we're defining in the variable IP address, we have the address field assigned to a string, and this is what that string representation looks like. And then we're saying it's a v4. Now here we have the another one called loopback, and here's that string, and then here's that enum usage. So pretty simple so far, right? So let's take it a little bit further. So notice we have the IP address now as an enum rather than a struct. And then here's that case, or that different variant, v4, and we actually have a parameter that we can pass with the variant. So we got that string, which would have been the address in the struct from before. So notice here, this is on line 22, a way we can pass in the string, but for this particular variant v4. Same thing on line 22, we have v6, pass in that string there. Now looking back at the IP address here, we actually have two different ways that we can have the variants. They don't have to have the same types for parameters, and you can have multiple parameters for the equivalent variant. So in this case, v4 takes, it looks like 4 different unsigned 8-bit integers, and then you have v6, which just takes the string like before. And then here's how we can use them. So we got home and we got loopback, but now the way we define home, here we put in all those different integers, and then for v6, we just give it the string. Now to build on more variations of the enums here, just notice that those types don't have to be just strings and integers, but they can also be structs. So here's an example of a struct which is an IP4 address, and then we have a IPv6 address here, and those can be used with this struct that we have here, the IP address enum. And those can be used with the enum for IP address now for the different variants. So let's look at a comparison of what it would be like to define something as an enum versus a struct. So here we have the enum message. Here we have the variant of quit. We have move, we have write, and we have change color. Each of them have parameters, or like in the first variant, we don't. Let's look at what the equivalent with separate structs might be. So here on line 24, we have the struct that's like a unit-like struct, so we don't have any fields at all with it. So we don't have any fields at all with it. And then we have move message, then we have the write message, and then we have the change color message. So the disadvantage here would be that if we wanted to take this type, quit message and move message, and make them as function parameters, we would have to do it separately for each one of these variants or each one of these cases. However, if we just say it's one of the variants of message, we can pass in any one of these. So enums can actually also have associated functions just like structs. So if we look here, the implementation of message for the enum message, we just have this function that we have, and it's call. So it's a method. and it's a reference to self, which is owned by somebody else. But there's no implementation because it's just the example. Now here's an example usage of it. So let's say we have a message and it's the variant right. And then that takes a string, so we have the string there. Now we can use this call method for that particular variant. So it's pretty cool. It's very similar to Swift, if you've seen Swift, and doing like enums with extensions, or even structs with extensions. But it's a very powerful feature. So let's move on to a more common enum, and this is the option. And this comes from the standard library with Rust, but essentially what we're looking at is using it with an advantage that we're not using null or nil, depending on your language you're coming from. So option is an enum that represents a value either being there or not being there. This is actually similar to Swift and TypeScript optionals. It's not exactly the same, but let's discuss what option is within the Rust context. So there's a little excerpt in the Rust programming language book in chapter 6 about nulls and how you shouldn't use them. They're like the $1 million mistake, probably like $1 billion mistake by now. So here's a sample of how option is actually defined for us in Rust. So here's an example of the enum option as it's defined in the standard library for Rust. So it's an enum with option, and we haven't really talked about this yet, but it's a generic T, so it's any type. And then we have a none case, which means the value's not there. And then we have something there, which is represented as some. And then it actually has a parameter that's passed with that variant, so that's the actual value itself. The prelude of Rust also gives you some and none as just like these global things that you can use. So we'll look at some examples with that in a moment. So here on line 16, we have an integer 5, and it is some number because it's wrapped in this sum that I was just talking about. And the same thing here with a string, it's some string. Now, if the number is absent or not there, you can actually use none here. Now notice with none, you can't just say equals none, kind of like we have equals some here. The compiler does need to know what type it actually is, so you're gonna have to use this colon, space, and then defining option with those little angle brackets there, putting in the generic type. So in this case, we're not using type inference anymore, but we're being very explicit about what the type actually is. So now what would the advantages actually be? So here I have this example of main, and it has some y. Now it is an I8, just like x is, and we want to add those two together to get a sum. So let's build and run, and let's see if we can print out sum. So we actually get an error with this. So notice it says there's no implementation for I8 plus option I8. It's trying to give us some sort of help on like how to actually overcome this issue. Yeah, but essentially this is not possible. It's pretty evident in line here. We can see what the value is, but if this is a return value from another function, we don't know if we have none or not. So it's actually not deterministic to know if that something is here. So with these kind of constraints, we can actually use this to our advantage with Rust code, and in this case, it won't even compile. We can't even ship our application or our program without actually satisfying the compiler needs. So let's take this a little bit further, just so you get an idea of how to overcome this little issue. So here's an example of getting the sum, but this time with y, we actually have this special method that we can call on the option, and it's unwrap. Now this is actually potentially dangerous because, well, we know in this case it's going to be 5, but if it was none, we'd actually get an error. So let's run this right now and let's see what kind of output we get. All right, so we get the sum is 10, so it actually works, so that's good. So really quickly, let's just change this to none and build and run again. All right, so we actually had a panic. So this is a runtime error. So it wasn't caught at compile time, and that's why this unwrap function on its own is a little dangerous. So now what if we actually wanted to unwrap this, but if we didn't find anything, provide some sort of value? So in this case here, let's say if y actually didn't have a value associated with it, let's just give a default of 9. So in this case, we would actually get 10 on the command line because we do actually have a 5 here. Now in Swift and TypeScript, you might use this double question mark, this like null or nil coalescing operator. So that's a special operator in those languages, so you can get like a default value, very similar to what we wrote here in Rust. Another variation of this could be the unwrap or default. Now, not the default like value, you don't provide what the value is, but a default for some of these values, like say a string would be an empty string, or like an integer would just be 0. So I don't recommend using unwrap on its own because it could lead to runtime errors. But if you're just experimenting, just trying things out, by all means, you have these tools, so go be creative with them. So let's look at match as a control flow construct. So match is used to compare a value against multiple variants, and then also use it with pattern matching as well. And if we match that pattern, then we can run some code. Some of the acceptable patterns we can use are actually literals, like literal values, variable names, and then also wildcards. Chapter 18 of the Rust programming language book actually covers this a little bit more in detail. Now, the most powerful feature of the match is that the compiler can reason about your code to make sure it satisfies all of the cases that it could possibly run into. So matching on an enum so that we can see which variant it is actually a very common way to use this match. So here in this example, we have on line 15 a coin that's been defined. Now the coin, we have penny, nickel, dime, and quarter. Now we have this function that wants to take a coin. And if we match against it, then we have all of these different cases that we can test against. So it tries to see if it's the variant penny or nickel or dime or quarter, and then it gives you back the appropriate value. And that's what this is doing here. Now, if we forget one of the cases, we'll actually get a runtime error. So like here, we forgot quarter. Maybe we commented it out or we just didn't write it. So cargo build. So here it is saying the pattern quarter was not covered. So we don't have to actually just return a single value. We could actually run multiple lines of code. So here in this example, we have penny that's been matched, and then we can run multiple lines here. And we put it in this block here. So we have the opening wing brace and then the closing wing brace. We're going to print something out, and then we actually return 1. So now let's say we actually wanted to take the quarters, and we're going to use them with like all the US states, because in the US, every single state is represented on a quarter. So we have the enum US state. We could list them all out, which I've neglected to do so in this example, but you get the idea. And then in quarter, we can pass in the parameter US state. So we can match on that. So here it is. We have, if we match on quarter, then we get state, which could be any number of those variants in the enum US state. And then we can also return 25 like before. Now let's combine option, the enum, and then also match, and then try and look at how they relate to one another. So here's an example of combining pattern matching with all the cases of an enum, and this enum we're using is going to be the option. So on line 15, we have +1, passing in the option, and then we match on it, and we're matching on none. So if we don't have something, we return nothing, and that's okay because the return type is also an option. But if we do have something, then we're actually just adding 1 to its original value and then returning that. So here's an example of using it on line 23. We have sum, so 5 is wrapped up in there. And then we also have 6 because we're going to do +1 on it. So we could just pass it in like so. Or we could do none. Or we could have taken this sum 5 and put it right where the 5 variable is there too. Both will work. So now what if we didn't write the sum part here? Could maybe Rust assume that we return nothing? Let's build and see. All right, so we actually didn't match that pattern none. So we would have to provide it if we're going to use this match. So here's another example. We have a dice roll, which is going to equal 9 for now, but you can imagine its variable could be any other value. Now, if we match to 3, we're going to run this bit of code. If we match to 7, we're going to run this other one. Now, here's the thing. The integers, there's a lot of them. So we're not going to want to specify every single match. So we're getting this like wildcard match here where we're saying, well, if it's not 3 or it's not 7, if it's any other value, then match this last case here on line 20. And then we could do something like, pass that value into another function or do whatever we want. Now, let's say we didn't need that last value that we matched on. We could actually match on just nothing. It's like a placeholder here when we use the underscore. So in this case, we're saying, well, if we have something that's not a 3 or not a 7, we don't need the value, so we're just going to say re-roll. Now here, this last example, if we don't match on 3 and we don't match on 7, we're not going to use that last value, and we're actually not going to do anything. So this is like that unit type again, where we just do nothing. So now this example shows pattern matching, but we really only care about one of the variants. So here, line 15, we have some sort of config max value. And if we have something, then we're going to print it out. and then we don't do anything, right? Well, there's another kind of syntax called the if-let. So let's look at this. So if we just have the one case where we just want when something is actually there to then use that value, we use if-let, and then we put the sum in there and whatever we want the variable to be called. And we're getting that from this max or this config max. And that value is now there. So we can use it. This is very similar to Swift. So if you have used Swift before, this is almost exactly the same, but there's a slight difference in syntax. You can think of this as like syntactic sugar though, for really doing what we have in the code up above. So use if-let if you really just want to check and see if something actually is there. So now let's go back to our coin and US state example. So here we have that match where we just have the wildcard there where we don't really care about what the value is. And then we're doing something here. Now here's the if-let equivalent of that. Now we're saying, well, if there is a quarter with the state in this coin, then we want to use it. Now this other part here, there's an else block we can use too. We can say, well, if we don't have that, then do this. So these two are equivalent. Here and the else. So now we've covered how to use enums in Rust. If you guys have any questions, let me know in the comments below. I will do my best to answer them for you. Otherwise, I'll see you again in another video.